Alright, for this video, we're just going to graph number 1 on the notes, just the y equals sine of x over 2. And the only thing we're going to do is change the amplitude. Well, actually, the amplitude's still going to be the same for number 1, but we are going to change the period. Now, every single one that we graph is going to be in this form. The number outside that's multiplying sine and cosine this a, we say this is the amplitude. Now, just like you learned in physics, this affects how tall the wave is. Then another important thing is, well, how many cycles are we going to go through? Now, normally you go 0 to 2 pi. Now, we're only going to look at, for the first day, where we change a and b. This b value basically changes the period. So this 2 pi over b gives you the period of each trig function. And then what's also is real important, you're going to get 5 key points when you graph these. And when you graph these, you always do whatever the period is divided by 4. Because there's 4 x and y intercepts in the unit circle. Okay, so let's apply this to the sine one right here. Now the first thing we see, there's no number written next to the sine, so it's assumed to be like 1 times the sine of x over 2, so the amplitude's 1. Well, what does that mean? That means when you do this, the maximum y value is going to be 1, the minimum y value is going to be negative 1. On the curve, or on the wave. And the point that's right in the middle, which I usually call, hopefully I already told you about this, is the equilibrium. The point that's right in the middle is going to be 0. These right here, 1, negative 1, and 0, these are going to be the only y values that we're going to graph. Okay, the period is 2 pi divided by b. In this case, b is 1/2, it's not 2. This is like saying 1x over 2, so the coefficient for x is 1/2. Now if you do 2 pi divided by 1/2, that's the same as multiplying it by 2. This is going to be 4 pi. So horizontally, we're going to stretch this wave out. Instead of going from 0 to 2 pi, like we do in the normal unit circle, we're going to go from 0 to 4 pi. Now in increments, this is real important to get all the x values for my 5 key points. The increments, right, I follow this right here. I take the period divided by 4. So if I take 4 pi, and divide it by 4, the 4's cancel, and I get this to be pi. So you always want to get these 3 values first. Okay, now let's go to the key points. Now for all of these, for these graphs the first day, we're not shifting anything horizontally or vertically. So if I'm not shifting it horizontally, I'm going to start at 0. That's going to be the first x value. Now I'm going to get the x values first. The next x value, I just add the increments to it. So I keep adding pi. So if I add pi to this 0, I get pi. Okay, add pi to the pi, I get 2 pi. Then I get 3 pi. And if I add pi to that, I get 4 pi. And that makes sense because if I look, the distance from 0 to 4 pi is 4 pi, and that is the period. So you're kind of checking your work as you go along. Now, the key points, the y values, as I said before, these are going to be the y values right here, 1, negative 1, and 0. Now, from graphing, using the spaghetti activity and the Twizzlers, we're going to see sine always starts at the equilibrium. It always starts at this 0. So this is going to be 0 right here. Now, since this is positive sine of x over 2, then we go to the max. So it's going to be the 1. Then when you hit the max, you got to go back down to the equilibrium of 0. Then you keep going down to the minimum of negative 1, and then you got to go back up to the equilibrium of 0 right there. Okay, so it's going to follow that pattern. Domain for all of these, it's always all real numbers. The range is, well, you really can use your max and your min. So the range is just negative 1 to 1. Okay, then you have everything there to graph. So let's move this up. Okay, I'm going to graph this. Now I'm going to label the x-axis. Let's say I say this is, I'm going to go every 2. I'm going to go pi. This is 2 pi. This is 3 pi. And I'll put 4 pi on the outside, just to evenly space everything. So I have 0, 0. Pi is at the max, 1. 2 pi is back at the equilibrium. 3 pi is down at the minimum right here of negative 1. And 4 pi is back at the equilibrium. So if you connect it, we go up to the max, come back down, go to the minimum, and that's our sine wave right there. Okay, so that's pretty much it. That's your sine wave. You always start with the equilibrium for the y value for sine.